Welcome to the shop. I'm continuing NQALHA Production Run 5. Not sure exactly how many units I'm going to be making, but it's going to be more than the last run. The Production Run 4 was 10 units, and I sold them all in a week after they were available. So I'm going to make more this time, not exactly sure how many. And I'm also continuing to learn the my new Haas mini mill too. So far, the machine itself works amazingly well. The software is maddening and frustrating. It kind of feels like going back to the 70s, maybe even going back to the 60s. I mean, it's got a lot of weird quirks. And probably the most annoying thing that I had to deal with is the tool management. The Tormach, which is a hobby grade machine, and I assumed that a professional grade machine would outperform a hobby grade machine, so I never questioned this before I got the Haas, but the Tormach has a 10-position automatic tool changer. I have 60 tools in my tool library, and in the Tormach you just say, oh, store tool 41, it puts it wherever it fits. No problem. Then I get this thing, and it has a 20-tool tool changer, and it only understands 20 tool numbers. So what do I do with tool 41? It turned out to be quite a major annoyance. Fortunately, I'm a programmer, so I was able to create a post processor that used, and then I created several different tool sets, a standard tool set of 13, or actually 14 tools, 13 tools plus the probe. The standard set of 14 tools that's used in almost every part, and then additional sets of 6 tools that are swapped out as needed, and created a program that managed tool number, the T parameter in G code, against offset number and offset diameter, the H and D programs in G code. So now tool 41, let me see where tool 41 actually is. So tool 41 is now located in tool pocket 14. So the program G code calls a T14 H41. Now, I did get the automated probing and automated tool setter option, which is just plain amazing, and then created a custom G code program to look at the particular tool set that was loaded, and then automatically set the appropriate tool offsets. And I thought that I'd just demonstrate that for you in case anybody was curious before I get down to actually making NQALHA parts. So I've got the program loaded, and I put in option stops so that I can check and double check and triple check and then check again, because, you know, 2 reasons. I'm new to this. I don't have my habits completely refined and under control and practiced and kind of integrated into my work routine. And there's a lot of room for error. When you're doing things that are manual, where it's not being done by the computer, there's always a chance of making a mistake. And yes, I'm not perfect. I make lots of mistakes. So anyway, I'm following the procedure, double check, triple check, cross check. I've got my list up here of standard tool set, position in tool holder, and tool offset number. I also have the tool offset numbers marked on the tool holder using what Dymo claims is durable chemical resistant labeling tape, and we'll see how it holds up to coolant and high-speed operation, but you know, so far after a day or so of working, they're still sticking on. So I'm going to start here with the optional stop. Starting at tool 1, then I use the old eyeball and say that, tool 1 is actually tool offset 1 in my library. Go over here to the G code and look at the probing macro, and the probing macro is set to probe tool offset 1. Tool 1, check to see tool 1 H1, 1/4 inch 3-flute carbide, looks correct. Going over to the probe, it's what they call the WIPS, the wireless, I think interactive, wireless something probing system made by Renishaw in the UK. And unlike the probes or the Tormach that was wired, this probe can actually be put in the tool changer and inserted like any other tool. It can also be used in process. And I'm not showing probing now, obviously, but I'm still talking about the system. But the probe can be used not only to measure the work offset of a blank or a 1, 2, 3 block for setup, but if I ever really wanted to get crazy, the probe can also be used for in-process inspection to verify that the part was made according to the spec provided. So next tool I'm looking is tool 2, offset 3, looking at the table here, T2, offset 3, looking at the G code, offset 3, and this probing operation is, when I first learned about it, it really surprised me. I thought, wow, I didn't know that was possible. It is probing an end mill while rotating, and it's both probing the length and the diameter. And the diameter is used for tool wear compensation. So if after making a number of parts, the tool just happens to wear down a 1/2 thousandth, the probe supposedly is advertised to be able to accurately measure the actual cutting diameter of the tool. And of course, with a 3-flute tool, you can't use a micrometer. In the past, I would plunge bore a hole using the tool and then check it with a gauge block and use that for my tool wear adjustment. This should be a whole lot better. Okay, next tool, tool offset 48. Tool 3, offset 48. This is the 3/8 3-flute roughing cutter, the Lakeshore Carbide aluminum shredder. Go over here and verify yes, T48 in the G code. And this one, since it's a roughing cutter, will not be probed for diameter because it's a roughing cutter. Who cares? I don't care if it shrinks by 1/1000th, as long as it keeps cutting. So now, tool offset 4, which is also, just by luck, happens to line up with the pocket numbers. So it's tool 4 in the changer, offset 4, 1/2 inch 3-flute Lakeshore Carbide aluminum cutter. Checking to see here, tool 4, tool 4. It will also be probed for while rotating for length and diameter. Now, I was totally surprised to learn that it's possible to probe a tool while rotating. And another thing that I learned when I was watching the Haas educational videos is that the rotation is always in reverse. And of course it makes sense. If the rotation was in the forward direction, then the cutting edge of the tool could grab the probe and make it very unhappy. So the tool is running in a reverse orientation and very carefully touching off on the measurement probe, and supposedly they say that it's being measured within tenths. So we'll see. One of the things that I plan to do as I gain familiarity with this machine is just see how accurate can I make parts. Can I hold 1/1000th? I don't know. I never could on the Tormach. The salesman tells me, oh, you can hold 1/2, but hey, that's a salesman. I'm gonna, always be trust but verify. Always going to be measuring in process, taking a day off production just to do measurement investigations, and just find out how accurate will this machine work. So the next tool, tool 23, tool offset 23, and tool location 5, 832 tap drill, verifying in the G code, tool 23, tool 5, only measuring the tip height with this because it's a drill bit. I drill through, the diameter is whatever the diameter is, and I drill through a little extra to kind of avoid a big burr on the bottom of the hole, so this one ain't really that critical. Next one, tool offset 24, and yes, in fact, it is a spiral tap, an 832 tap, offset 24, tool position 6, checking tool position 6, offset 24. This procedure that I'm going through reminds me of my time as a pilot when I would go through the checklist, item by item by item, line by line. And when there are so many problems that could occur here that could result in very serious damage, it really is the way I have to do it. Every time, follow the checklist, don't miss a step, check again, check again. Tool offset 26, which is a number 10 clearance drill. This is the tight clearance drill, which is a number 10 drill that fits very tightly. So tool changer position 7, offset 26, check the G code, offset 26, tool 7. The recommended, if you look in a standard chart of clearance hole diameters, they're all too big. And so I very carefully examined the actual diameter of the screws I use and determined that when I want a tight fit, I can actually go a little bit closer than the recommended size. So this drill, which is number 27 offset, is a number 9 drill in position 8, which is the recommended clearance hole if you want a sloppy clearance. And sometimes I actually do want a sloppy clearance, especially on the magnet clamp portions where there might be a little bit of a bendiosis going on. And so I like having the tight fit as well as the loose fit. And so while I'm talking, I could be making a mistake, so I'm going to stop talking. Well, not stop talking, but think about 27, position 8, position 8, position 8, 27. Go ahead and run the sucker. And yes, my most common tools that are used very frequently are 3/8 finish end mill, 1/2 finish end mill, 3/8 roughing end mill, 1032 and 832 drill tap and clearance, and the 3-inch insert shell mill for skinning the surface. Tool 28, which is a 1032 tap drill in position 9, position 9, tool offset 28, 28 marked on the tool holder. Double check, triple check, check again. I have no doubt that one of these days I'll make a mistake, but boy, I'm hoping it's not serious. In the years I had the Tormach and the thousands of parts, many thousands of parts I made on the Tormach, I did make some mistakes, but never. The worst I ever did was I broke a tool, ruined a part, and occasionally poked a hole in a soft jaws, but I never actually hurt the machine. So I think I've developed some fairly good habits, and as long as I just pay attention, I think I'll be okay. 29, which is the 1032 spiral tap in tool holder 10, tool holder 10, offset 29. The mini mill, unlike the Tormach, the mini mill actually does real rigid tapping, and so far appears to work exceptionally well. One of my parts does have a 440 tapped hole, and we'll see how the 440 rigid tapping works. I mean, it worked on the Tormach, so should work even better on this. Tool number 2, which is in position 11, 5/16 3-flute carbide, which happens to be the counter bore hole for a number 10 socket head screw. Tool offset 2, position 11, offset 2. Now supposedly, if you believe the advertising and believe what the salesman said, when the machine wakes up in the morning and goes through its zeroing cycle, it should zero itself accurately. I mean, accurately enough for machine work. I'm going to continue to verify this before just blindly trusting it, and pretty much every time I start up, at least in the beginning, I'm going to calibrate work offset, calibrate tool offset, and start measuring things, and put on an indicator and just find out, okay, the salesman tells me the machine wakes up knowing where it is. Well, let's verify that. So tool number 31, which is a 1/4-inch stubby drill bit in position 12, offset 31, 31 marked, and the bit actually looks like a 1/4-inch bit, so all is well. And then the last tool in the standard set is my newest tool. The Tormach never could spin a 3-inch 6 insert face mill, so when I did face milling on the Tormach, I used what they called their Superfly single cutter fly cutter, and it worked well, but this thing is such a nice cutter, and it will be probed while rotating, which is an amazingly scary thing if you think about it, because that cutter could just destroy that probe so easily, but it doesn't. You know, the machine does what it's supposed to do. Tool position 13, offset 58, 58 is marked. Cutter is obviously a 3-inch shell mill. 58, 13. And it's going to probe while rotating. Amazing that it even works at all. And I'm not probing the diameter because I only use this tool for facing and don't really care about what the outside diameter is, but the probing macros actually have a parameter so that in this case, the insert is a square insert with the point facing downward, so it's got 4 cutting surfaces that you can choose. If I wanted to, I could specify where the perpendicular point was and actually measure the diameter of the tool at its largest point. So probing is complete, and I'm gonna go over here and jog into position. This part is going to be the bottom vertical arm, and I've cut the blank to size roughly on the chop saw and deburred the end. The saw actually makes very, very little burr. It's a special aluminum cutting blade that produces a reasonably decent cut, reasonably free of burrs. I deburred it on the Scotch-Brite. Gonna put it into the vise. Because it's such a long part, I need to, oh, where's my handle? There's my handle. Because it's such a long part, it has to be held in both vices. I like to keep my vise set up standard for all parts, so I don't have to like move them around and re-indicate them frequently. I'm trying to get thickness fairly accurately. The material, this batch of material comes in about, I don't know, so it's nominal 375, it comes in about 382, something like that, 380.5, something. Oh, I don't even remember. Now I'm trying to remember. It's a little oversized. It's 5 thou oversized. So I'm taking 2.5 thousandths off each side to come up with a finished size of 375. And in yesterday's video, when I was making the parts for the top vertical arm, I don't know if you watched the video, but I measured one after it was done. It wasn't quite what I wanted. Close enough, certainly usable. I assembled it onto some parts. It works perfectly, but I'm trying to get as accurate as I possibly can get, and I wondered why wasn't it that accurate. And I checked and rechecked and measured my new soft jaws, which are the first parts that I made on this machine just for practice, and sure enough, the soft jaws had a tiny little error in them. So I corrected the error, and in case you're wondering where the error came from, it's not paying attention to reference surface, using the wrong reference surface that wasn't the most precise surface available. I took a piece of raw aluminum extrusion, put it in the vise, probed the top of part, and then commanded the machine to move down a certain increment. Well, okay, what did I just do? Now my measurement is dependent on the mill tolerance of the material. Duh. So stop being stupid, dude. This time I probed the vise bottom surface and then commanded the tool to cut a measured distance from the bottom up to the ledge. So the material is irrelevant. The reference is now the back of the vise and the bottom of the vise, and the material can have its own tolerance. So, you know, even as hard as I try to be smart, sometimes I'm just plain stupid. I hate being stupid. Get out Mr. Whacker. Load up the program here. The user interface on this really, I mean, it feels like being on a teletype in the 60s. I don't know. The machine is magnificent. The software is piss poor at best. So here we go. Boy, that thing has great rapids. And yes, talking about double check, triple check, being careful, I've already made 5 or 6 parts before I started the camera running And when I made the first one, I went through my standard setup, which is, oh, what's that? There's a, I didn't know that. I guess there was an option stop in my program, and I left option stop configured from the last one. Here I am talking about making mistakes, and yep, there's a non-serious mistake. So, anyway, before I made the first part, which was off camera, I followed my standard setup procedure, which is to operate in 25% feed, single step mode, and pay close attention to the distance to go indicator on the display. All of my toolpaths, the CAM system puts in the first Z move is to roughly an inch above the surface. So with the rapid slowed down, I can, if I have my finger on the stop button while I'm doing it, I can see, is it blowing through that 1 inch? Stop it if it is. And then when it stops, I look over at the distance to go and make sure the distance to go is no more than 1 inch, and then push the go button and make the pig oink. So this is a toolpath that's known and trusted, that was run probably 6 times before I turned on the camera. I'm using the recommended feeds and speeds, recommended surface feet per minute, as recommended by the chart in BobCAD, which is pretty much faster and more aggressive than anything I ever was able to do on the Tormach. And this machine has great rigidity. I have no chatter problems, no spindle horsepower limitation, no tool pullout, everything. The machine itself is a wonderful machine. I love the machine. So I suspect that as I continue exploring, I may be able to push a little bit more aggressively, possibly using carbide drill bits instead of the high-speed drill bits for those applications where I'm poking a tremendous lot of holes. I may actually get some carbide bits, but you know, this really isn't that slow. The cycle times are dramatically less than they were on the Tormach. So, that, let me see if you can see it there, that is just a beautiful surface finish. And not only does the skinning operation result in more accuracy, where I'm not depending on the mill tolerance of the material, and I can get my dimension controlled a little better. Not only do I get better accuracy, but you know, a lot of times this material isn't handled very carefully. The material supplier scrapes it and scratches it and dings it up, and when in the past, when I just used the mill finish, I'd have to spend a lot of time on the Scotch-Brite wheel manually sanding out all the scratches, and well, some of them were too deep and I just got tired of Scotch-Briting, and so you know, some of the machines have a tiny little scratch in them. But in the new world, I got clean surfaces. Clean, beautiful, dimensionally correct surfaces. So, that's the first operation. I'm gonna run some more parts and turn the camera back on. for the second operation. All the material I have in stock next time I go get material, I'll probably get enough to make some more parts, but for today, I'm just making what I have in stock. Still not sure exactly how many units to make, but I'm sure I'll figure it out eventually. So I'm going to show some more of the setup details here. I'm going to be probing the corner of work offset 5, and this is a special work offset that's not used very frequently. It's the ledge of the soft jaws and then the right rear corner, and my probing routine, which is a custom piece of G-code that calls the Renishaw macros, the probing routine knows, let me make sure I got the right one here, G58XYZ, and I'm checking by eye all of my G-code, even though I know it's right. In the early days of doing this, I'm checking and double checking and triple checking. So the G-code measures, using the Renishaw probe, it measures the top and the right rear corner, then subtracts the thickness of the 1, 2, 3 block, which is a precision 1, 2, 3 block that I actually measured with a precision micrometer, and it's maybe a tenth over, maybe a half a tenth over 1 inch. So 25% rapid, single block. Moving down to a safe height above the surface, so I know that's always going to be safe. It's in machine coordinates, so it doesn't matter if the work offset gets screwed up. That's telling to move in machine coordinates to the safe location above the 1, 2, 3 block. And then I'm looking here, and yes, I'm going to be setting work offset 58, which is correct. Let me think about that. Yes, it is correct. So now I'm going to run the Renishaw probing macro. Turn the probe on. Then go to the corner. And there we have it. So in a handle jog, put away Mr. 1, 2, 3 block. And my part, as I was saying before, keeping a reference position in mind is really important. the top surface was made with this corner as the reference, so I can't just flip it over, because if I did, I would be counting on the material being perfect and the cut being perfectly perpendicular and smooth, and both of those aren't correct. So I got to keep this as the reference corner as I flip it over, and that's why it's using the different work offset. So checking against my sanity checker here. So many places to make mistakes. I've always, just as a general rule, tried to automate as many things as I can, not necessarily because I'm lazy, and well, yeah, I am lazy, but when you automate things and debug the program, it should run correctly every time you run it. When you have to think through a series of manual steps where each one there's a chance of error, it's just far more things to watch out for and far more places to make a mistake. So let's go over here to vertical arm bottom flip right 0, and gonna get that cutter lined up, single block, 25% rapid, checking distance to go, speed looks correct, going to be feeding down to approximately an inch with my finger on the Estoppo button. Look at distance to go, and Z looks sane. Take it out of single block mode, back to 100%. Taken off 2.5 thousandths to try to get to the nominal size of 375. Tool change at full speed, because I don't want to wait for the tool change. Back into single block, back into 25% rapid. Somewhat inefficient tool path there, going to the wrong hole. Maybe someday I'll fix it, but maybe not. Okay. That looks correct. Looks correct. Put it into regular speed operation. When I was using the Tormach for these are decorative chamfers. They just make the part look a little nicer. And because it's decorative, I wanted to make them look nice. On the Tormach, I had to futz and fumble around with feeds and speeds, and it seems like no matter what I selected, I'd get chatter, and then I'd get it working perfectly one day, and then come back some other time on the next production run the same program, and it would chatter. So on this, it's just so easy. Recommended feed and speed for high-speed steel, 508 surface feet per minute, using 1,000th of an inch feed per tooth, and hey, no problem. Part comes out beautiful. Oh, and I also added a 0.3 second dwell at the bottom of the stroke after learning about what is dwell and why do you use it. There are so many things to learn in CNC machining. But I love learning. Part of the fun. If it was easy, I'd be bored by now. So, look at the part. got my reference here. I usually mark with a Sharpie on the 0, but since I'm skinning it, well, the Sharpie mark would be long gone. So I've got a reference one here with the Sharpie mark on it. Compare that, flip, careful, careful. It's so easy in production just to try to get going too fast, leave out a step, make a mistake. And yes, I've done it. So here we go. %100% rapid, full speed operation. I may not every part in the project requires the best possible dimensional accuracy or surface finish, so I may not bother skinning every part, but boy, I sure like the way they come out. Maybe I will skin every part just because it doesn't take that long and they sure come out nice. And even after the operation of cutting with the shell mill, the surface finish is beautiful, but I'm going to still put it on the Scotch-Brite anyway for the decorative brushed finish, because I like decorative brushed finish. And I need to knock the corners off a tiny bit. And yes, I realize that I probably could use a chamfering tool, but because of the sequence of operations, when I cut the profile, it's on a tooling plate, and the bottom surface isn't available for chamfering, it's just easier to go over to the Scotch-Brite and knock the corners off. So that's it for second operation. I'm going to run the batch and then come back for high-speed machining, the third operation, profile. See you later. I'm just double checking everything here. I've got the tooling plate in place. I probed the top surface and set Z0 to the top surface of the tooling plate. And now I'm going to be machining the profile using high-speed machining operation. And I did a kind of a dry run, just watching the cutter move with no part in place. On this setup, I have to be really careful on rapids to clear the top of these guys, because it wouldn't be very much fun at all to run that cutter into one of these. So I believe everything is okay. I believe that I've made my sanity check using with just the tooling plate. I verified that the work offset was probed correctly by manually jogging the probe tip down and kind of eyeballing that, yep, that looks sane. So, high-speed machining, vertical arm bottom. See if we can make this pig oink. And since I've already kind of tested it, I'm just going to go for it. And, you know, this thing is so annoying. It keeps saying wrong mode. Why should I have to worry about the mode? It should automatically know what mode to be in. This is, I don't know. Maybe I just complain too much. Or maybe I'm right. Maybe the software does suck. $250 inches per minute, 10,000 RPM on a 1/2-inch 3-flute Lakeshore carbide solid carbide zirconium nitride coated end mill with a 100,000th step over and full depth of cut. You know what? That's a mistake. Oh, I hate making mistakes. Oh. That is a mistake. Now my question is, do I leave it in the video? Let people know that I actually make mistakes? Oh. So, that is a weird mistake. That is a very strange mistake. I'm not even sure why that happened. I gotta go back to the CAD room and check this out. There is something very wrong here. Even though production run 4 wasn't that long ago, how did that happen? I don't know. Yeah, mysterious mysteries continue. That is just way too weird. Just way too weird. I'm going to turn the camera off and try to figure out what's going on here, but there's the programs that I'm using here, the toolpath programs that I'm using are based on my old trusted Tormach programs that work just fine, and now there's all sorts of errors and inconsistencies, and I'm not sure exactly where they came from, so I need to pay attention to design and turn the cameras off. This is just too weird. Well, I figured out the problem, and as usual, it was just a stupid mistake, and I hate being stupid. So here's what happened. The previous tool paths that I've used for all of my previous work have been two-dimensional tool paths, DWG files, and I've imported those into BobCAD for toolpath generation, but the original drawings were 2D drawings. I do have a solid model of the NQALHA that I used during development for general interference checks and just to make sure that things looked right. But in the past, I've always made my toolpath, because most of it really is. It's profiles. It's not 3D contouring. And it just seemed to be easier to use 2D drawings. So it turns out that BobCAD will not do, or at least I can't figure out the option to command it to do, adaptive, what they call the adaptive roughing or high-speed machining. You can't get that option on a 2D toolpath. So I ended up having to create a solid model of the piece that I'm working on in SolidWorks and then import that into BobCAD. And sure enough, I flipped it. And I don't know why, just stupid mistake. It's like I'm thinking so much about, oh, new machine, gotta be so careful with the new machine, and really seriously paying attention to things that are happening while I'm on the machine, and then just not even noticing that I made a stupid CAD mistake. that, I've been doing CAD for years, and I should have caught it. It's fixed now. It didn't hurt the machine, it didn't break a cutter, it did ruin a part, but oh well, if you're gonna make a mistake, might as well make one that has so few side effects. So I've got another part loaded. I've already done a sanity check to verify that it looks somewhat sane, and I'm going to go back in the CAD room and make one more quick check. I'm sure it's right, but after this mistake, I'm going to go check again. Double check, triple check, check again. I'm sure it's right. I'm sure I don't have a problem, but hey, let's load it again. And of course, another rant about the software. I'm looking in the directory listing, and the time last modified doesn't fit in the space allocated for it, and so the time is cut off. Fortunately, the toolpath program does put the time in the G code, so I can look at the time in the G code, look at the clock on the wall, and have some sort of confidence that I'm not having a revision control problem. But still, what the fuck? How can a programmer make a mistake like this? I don't know. Wrong mode. It should know. "250 inches per minute, 10,000 RPM, 3 flute, X over travel range." It just never gets easier. Oh well, doesn't look like it ruined the part, but X over travel range. How can that possibly be? Oh, if it ain't one thing, it's another. So when I was setting up the 2 vises on the table, of course, even though I got the Mini Mill 2, which has a longer X travel, it's still limited, and there's still a number of things that have to be taken into account. And in particular, there has to be room for the probe and for a larger tool. I suppose I could elevate the probe and get this vise a little bit closer, but I kind of wanted to keep the probe somewhat protected. I assume that it's designed to operate in a machine tool environment and that it's going to be safe there, but I thought, well, maybe not having the vise right up next to the probe would be a good thing. So I ended up putting the limit of the machine just a little bit off the left side of the left vise, and sure enough, the high-speed toolpath ends up wanting to take just like 0.02 more travel than I had available, and the machine, if it's not available, it's not available. It doesn't matter if it's only 1,000th. So anyway, for anybody that doesn't understand this, I know that anybody who's a machinist or knows anything about machine work understands this, but maybe not everybody watching these videos is a machinist. In order to set up vices on a machine tool, it's necessary to align them so that they're precisely parallel to the x-axis travel. And this is done using an indicator. I have an indicator set up here. It's a 0.5 indicator. So every marking, every line on the face of the indicator is a 0.5. And I've already pretty much gotten everything into alignment. The procedure is to tighten one vice screws and the other one's just barely snug, and then take Mr. Wacculator and ever so slightly and gently bop it around a little bit until you can sweep across the entire vice surface. And that vice is probably within a tenth. I can't see the needle move at all on the half-thou indicator. And then I'm also going over here to the right vice, and that one looks like it's maybe 2/10 off on that end, and you know I'm not going to dick with it. Maybe some other day I'll get crazier, but as far as today, I'm going to call that macaroni. And then it's necessary, as you're tightening this thing to get the final tightness, to do it very gently and carefully, with the indicator still in place, because even though theoretically nothing should change, well, sometimes it does. So I'm still, that needle is not moving at all. I see nothing on the indicator. So now the left vice is actually a tiny bit better than the right vice. Okay. I'm continuing to use the Tormach vices. When I sold the Tormach, I didn't include the vices in the sale. And yeah, maybe someday I'll get some better vices, but for today, hey, the Tormach aren't that bad. They do the job. So now I can get a chance to demonstrate one of the other things that I do here in the shop. Normally I just use the handles, but for rapid motion, put the tool on it. Then I'm gonna get my newly made, and I actually engraved their specification on them, because now engraving is so much easier than it ever was before. There's like a G-code in the system that automatically does engraving without having to find a font in the CAD system and generate an engraving toolpath and all that other happy crap. So I indicated against the precision surface of the vise, and after indicating to the precision surface of the vise, machined the soft jaws. So until proven otherwise, I'm assuming that I can just change out soft jaws using a Harbor Freight special El Cheapo, but certainly very useful. And of course, wipe it good. Everything's got to be clean, no chips, no dust. Using a Harbor Freight right angle air ratchet, that makes it a little bit more pleasant. Trying to Trying to change vice jaws with a regular hex key, I don't know, some guys do it, but that's just not for me. So, you know, Mr. Whacker. And of course now I have completely lost my work offset, so take out the precision 1, 2, 3 block and reset the 0. So my fancy program here is not going to help me out because my program assumes the vices don't move and all I'm doing is changing material thickness and making minor changes to the position of the stock in the work offset. And when I moved my vices, now my programs, let me check that corner to make sure that it's all good. Now that I've changed my vice position, my program doesn't work. So I'm going to have to use a somewhat more manual method here. I'm going to go ahead in wrong mode. You would think that it knows enough, but this wrong mode, I think probably if I'm still using this machine in 20 years, I'll still be in the wrong mode. Oh. Okay, so now I'm gonna go over to the what they call the VPS. So I'll be using a standard program that comes with the machine, and it's a slight bit more annoying to have to do it, but hey, at least I get the job done. Corner number 4, and get that guy in the MDI. Then handle jug, fast. Now when I'm not using my special macro, or not a macro, when I'm not using my special G code, set this up roughly by eyeball. So it's roughly positioned a ½ inch above the surface and eyeball at the corner, and then the Renishaw macro takes it from there. Let me make sure that I'm reading the G code and it's looking sane, it's looking entirely reasonable. So let's find out. Wrong mode. I don't know. Oh, so many annoying things about this machine. I love the machine, but boy, software is just driving me crazy. And of course, as a programmer who's been programming since 1972, I'm thinking, oh, come on, I could do better than that. I could definitely do better than that. What the fuck? So, MDI. And yep, let's give it another try. And the MDI, work offset 56. Now, believe it or not, and this is another thing that is just like when I found out, it was like, what the fuck? What's going on here? In the Tormach, it's got a button on the screen. It says, store the tool away. If you want the spindle to have no tool in it, it just says, store the tool. There is no way to store a tool and leave the spindle empty on the mini mill. Have to take the tool out. And of course now, reset, get into the right mode. Of course, in the software world, modal design is considered to not be a good thing. So, let's see if we have a slightly happier experience here. I'm sure that as I continue working with this thing, I'll come up with a compromise vise position that works for everything. And who knows, I might already have it. This might be a good position, but somehow I suspect I'm going to run into another problem somewhere down the line where the vises are not working for me. So CNC machining is very similar to aviation, and it's actually in a way kind of similar to writing software. In aviation, they say that there's nothing hard about flying, you just have to do 1,000 things right, and each one is easy, but if you get one wrong, you crash and die. In programming, every single step in writing software is so easy a computer can understand it, it's trivial. But there's tens of thousands of them, and you have to get each one of them right. And well, in software, usually the penalty is not quite as severe. In CNC machining, well, yesterday I had a problem to solve, and I fixated on solving that problem while ignoring another problem and ended up in trouble. So after a bunch of recovery that I didn't show on the video, and no, it didn't hurt the machine, it didn't break a cutter, it did ruin a part, and it did waste a few hours of my time, but okay, everything's back in control. Boy, there's a lot of little steps to get right, especially when learning a new machine and trying to make videos. Maybe I'm stupid for making videos while I'm learning a new machine. I don't know. But anyway, it's working now. So here's high-speed machining, outer profile, vertical arm bottom. Over here, select, and of course, be very annoyed that how come I can't see the time on the screen, but I can see the time over here. Time looks reasonable, and since I've already run it once, don't need to run it in safe mode. Let's just run it at full speed and let this see how this pig oinks. 150 inches per minute, taking a full depth 3/8, 375 deep cut. The step over is 100 thousandths, and it's a Lakeshore Carbide 3-flute, zirconium nitride coated, special solid carbide end mill designed for machining aluminum. Works really well. And yes, I did check the retract height to clear those giant ass hold down bolts. So many things that you have to check and get right. So many opportunities for error. A lot of shops have a setup followed by a long production run. In my shop, there's lots of parts. Each run is fairly small number of parts. So I'm almost always doing setup, almost all the time. I spend way more time doing setup than I do watching the machine run. Now I'm switching to a 3/8 cutter, also a Lakeshore Carbide 3-flute solid carbide zirconium nitride coated. And the reason for this is that I have, actually on this part, I could have used the 1/2-inch cutter for finish. Maybe I'll go back and wipe out a tool change there. On the vertical arm top, I needed that inside radius of the 3/8, but while I'm talking about it, I'm realizing, no, I don't need a tool change, so there we have it. And once again, an absolutely beautiful part, beautiful surface finish. I may have complaints about the software on this machine, but I don't have any complaints at all about the performance. The machine is performing magnificently. So that's going to do it for this video. I'm going to run the rest of the parts. I'm going to take out that tool change and just run the rest of them. And not sure, like I said in the last video, I'm not sure I'm going to show every single detail of every part. I might, maybe yes, maybe no, depending on how I feel about it. But for today, that's all. See you later. Thanks for watching. It's been fun and really challenging.